All right, ladies and gentlemen, our next guest is Marshall. He is a electrical engineer. He works with a lot of patients that have had strokes. He has just a background in neurobiology also. He's had to take a bunch of those classes. We're at the University of Utah right now, and he just does a lot of interesting research. And he's just agreed to jump on and help me out just to learn some stuff. How's it going, dude?
Good. How are you?
I'm good. I'm good. So we're talking earlier about you doing research where there's invasive technology and non-invasive. Can you tell us a little more about that?
Yeah, sure. So, especially with working with medical devices that attempt to interface with the nervous system, you can have non-invasive devices which don't penetrate the skin at all, and these are things like electromyography recordings or electroencephalogram or EEG recordings.
EKGs and all that
Yeah,
stuff too.
exactly.
Yeah,
So
yeah.
anything where you're putting like electrodes on the skin, that's non-invasive. And then for invasive is where you actually penetrate the skin, and this can be anything from like penetrating the skin for like recording EMG with like penetrating electrode, or like deep brain stimulation where they actually implant a device permanently inside the person.
Pretty much anytime you break the skin barrier
Yeah,
is
that's
invasive.
invasive. Yeah.
Dude, that sounds like a bad word though. Invasive.
Yeah.
It's invasive, like
Yeah.
you're invading someone's property. But
Yeah. Well, I mean, yeah, definitely. From like a treatment perspective, um, invasive definitely becomes a lot more expensive. You have to worry about things like infection. You have to worry about things like making the person uncomfortable, anesthesia, all these things that just really complicate the process. So my work focuses on non-invasive because we get to avoid all those issues, and it's just a lot easier to set up and a lot lower risk.
a lot lower risk. Okay, I got it. Because you don't have to involve a surgeon.
Hmm.
You just put it on, you take it off. Yeah, it's like putting on a cap, dude, for a neurofeedback machine.
Yeah, it's actually a pretty, yeah, exactly. It's exactly like that. So that's one of the non-invasive technologies we work with. It was actually quite cool. I got to work with, or I got to demo a product the other day from a company called Psionic, um, where so it's a non-invasive sleeve for the leg that does
Rest,
non,
restless lead for
yeah,
restless lead.
no, for gait correction. So after like a brain injury of some sort,
Mm-hmm.
people have like difficulty walking on like one or both sides of their body. And it's a sleeve that the person puts on that stimulates the muscles so that to correct for the walking. And it's actually really impressive to watch some of their videos online.
Cool.
Pretty cool. But yeah, so that's actually where my research works is non-invasive nerve stimulation for restoring hand function. So after a stroke or other brain injury, someone will lose function of their hand, and I'm looking at ways that we can use kind of engineering techniques and non-invasive stimulation to help rehabilitate that person and restore uh, function and like independence.
Okay. So you said it also depends on the work they put in themselves.
Yeah.
So, like when you work with them, if they're very ambitious, motivated, driven, they will heal quicker.
Yeah, 100%.
Versus people that just don't really give a shit. They're like, whatever. I don't care about this. My life is going down anyways. Like, what do you think it is about that actually helps the person like achieve their goal faster because they're motivated and everything else?
Yeah, so I mean, definitely. So how kind of like the basic mechanism of how the brain and like the nervous system functions is the kind of like saying, I guess, is nerves that fire together stay
Wired
together.
together.
Wire, exactly.
Yeah,
Yeah.
yeah, I've heard this numerous times.
Yeah. So and that's the idea is that so when you have patients in therapy who are like really putting in the extra time and really staying focused and working hard on it, they're just getting the nerves in their brain to fire that much more regularly, that much more frequently, and just giving their brain all the information it needs to relearn how to do something.
So it becomes unconscious in a sense.
Yeah, exactly.
So yeah, yeah, okay, got it. So the more times you do it, repetitions, the more used to it you get, and then you don't really have to think about it.
Yeah,
Your arm just
exactly.
starts working again.
Yeah, exactly.
And you were telling me earlier when people have strokes, a piece of their brain literally dies because the cells actually just die. It's
Hmm.
cut off from oxygen,
Hmm.
and then the rest of the brain has to like what does it have to? It has to like take the functions of the part of the brain that dies.
Yeah.
Can you explain that a little more?
Yeah, so Yeah, like you said, after a stroke, or
You say
other.
that.
Yeah, yeah. So
I'm just
or yeah, or other
quoting
like
you.
traumatic brain injury. It can be anything. Um, you have part of the brain that dies. However, um, your brain has a ton of redundancy in it. So like you don't have one neural circuit to control a finger. You have hundreds, thousands to do the same thing. Um, and so what happens is when you take away some percentage of them, the other ones have to get stronger to correct for those missing circuits. Um,
Got it.
and that's why, like we were talking about, like you have to get those the neurons that are left to rewire um, and wire together stronger than they were before to correct for the missing connections.
Okay. And let's say someone that has a stroke, and let's say a piece of them dies, and their left side is not functioning. Like
Mm.
if they work really hard, they're vigilant. Can they actually become like normal again, the way they were?
Yeah, yeah. So it does definitely varies a ton. There are kind of for stroke at least there are two kind of patients. There are ones that are people refer to as um, acute stroke patients. So they had their stroke like less than the definition kind of varies, but like 3 to 6 months ago.
Mm-hmm.
And they're chronic stroke patients. So patients that had their stroke years ago but are still suffering some of the side effects.
Chronic is ongoing.
Yeah, so they had a stroke and they were never able to like fully recover.
Okay.
Um,
Is that because they haven't had the proper training, the willpower, or it's a combination of things?
so it's definitely a mix of things. One of the biggest ones is the treatment that they necessarily received at the time. Another big one is the severity of the stroke. So I mean, if you have like
Grand mal seizure or something like
yeah,
that.
yeah, or just something like if you just have a really massive stroke or a really bad traumatic brain injury, like you're in a car accident, and
Yeah.
like if
Okay.
you can imagine like getting part of your brain like crushed in, but then
Holy
surviving, like you can imagine that it's going to be like almost impossible to restore certain functions because part of that like that part of the function is like entirely
Oh,
gone.
man, I don't want
Uh,
to say impossible though.
yeah.
Have you seen like miracles or like stuff that you're like, what the hell? This isn't supposed to happen, but it actually happens, and they're able to get back to health.
I personally haven't. A lot of
Have you
the
heard about it though?
yeah, you definitely hear about strange things. There's actually, I mean, there's probably one of the weirdest things I've read about recently was there's this professor, I think he's in Washington State, doing research with non-invasive spinal cord stimulation, and the idea is that you put electrodes on the person's like back,
Yeah, this spine. Yeah,
yeah, and apply electrical stimulus, and he was investigating it for um,
his wife.
no, for spinal cord injury, just in like different patients. So like for people who lost the ability to walk after some accident. Um, and it was actually quite cool because this is something that I had never seen before, is that they were just through non-invasive stimulation of the spine near the injury site, they actually got someone who had l- limited to no ability to walk to start to be able to actually feel things in their feet and move their feet on their own again, which is like unheard of. Like I've never
That's
heard like of someone like losing ability due to like a complete spinal cord injury, and being able to start to repair that through non-invasive means.
well,
Like
isn't
that is
that the machine helping the nerve cells fire together? And then
yeah.
after a while, they just start wiring together, and you don't really need the machine anymore.
Yeah, exactly. But for like for complete spinal cord injuries, like I haven't, at least I haven't seen anything like that that was done non-invasively. Like there are some like surgical techniques, but the fact that they, I don't know, they took like a just kind of like a basic like off the shelf stimulator and just stimulated the person while they tried to walk. And of course it was over like months, but the fact that they were able to regain function at all through like a really simple therapy is at least for me was kind of mind blowing
So
to read
at
about.
least it's possible, right?
Yeah,
Well, that's the
exactly.
magic of it,
Well,
dude. And that's,
yeah, and that's the cool thing is like this is stuff that's just people are just starting to look at. Like this is a like a pretty new cutting edge technology therapy. And
What's
so
it called?
so that one I think they were just calling it non-invasive spinal cord stimulation.
Just like
Like
something simple. Well,
uh,
but it was just one patient that happened to, right?
yeah, so that one was a case study where they
It
just
was
had
a
one
case study.
patient.
Okay.
But I mean, the cool thing with case studies is they open up the ability to like, hey, we got it to work with one. Let's see if we can get it to work with 10.
I'm sure
Let's
they
see if
can, bro. Eventually.
yeah, yeah,
But
exactly.
but here's the thing that I come across with a lot of scientists. Is now you're working with the consciousness.
Hmm.
Every single person thinks, feels, and acts differently, and they've been raised differently. There's like 8 billion of us, dude.
Hmm.
But then again, it's biology, so you could kind of replicate it.
Yeah, yeah, no, and that's I don't know. It is interesting to work at this intersection of engineering, technology, neuroscience, and then definitely, and some of the things even get into psychology, like consciousness and whatnot. And none of the work. So my work is purely
Yeah, yeah, I understand that.
with reanimating motor function and getting people to move properly again.
Yeah.
Um,
But here's the thing. Let's just say, yeah, you're working with the technology portion.
mhm,
But let's say you have the best technology and the person's like barely motivated. Is
mhm.
it really gonna work that optimally for them,
Yeah, I mean, I think it depends a lot on the scenario.
the individual too, right?
The individual, what you're trying to treat, and also what technology you're working with. Because I mean, so like, oh geez, I'm trying to remember. The company is called BlackRock Microsystems, and they're actually based out of Salt Lake as well.
They are.
Yeah, they're actually very old neurotechnology company, and they've been working on, and they're actually in. I think they're in clinical trials. I could be wrong. For developing, we were talking about this earlier, a neural bypass system,
Yeah. For the
where
spine.
for the spine exactly, where they would be implanting electrodes in someone's brain, and then figuring out what the person's thinking from those electrodes implanted in the brain, and then using that for the paralyzed patient to control something in their surroundings. And in that case, like that's 100%. I mean, obviously the person has to learn to use the device, and that's a huge key component. But the device is doing a lot of the heavy lifting.
But that sounds very pricey, dude.
Oh yeah, I mean
You
it's
know what I
very
mean? Like
yeah.
you have to get a neurosurgeon involved.
Hmm.
You have to get a lot of technicians involved, and then you have to constantly work with it, like have therapists.
Yeah.
That's very expensive, bro.
Oh, it's
Like, I mean, I feel like it can be available to the public, but I don't think healthcare industries are gonna approve it, bro. Like,
yeah.
400 grand? Oh, forget
Yeah.
that. You know?
Yeah, no, and that's a actually really good point. Is working. I've had some experience with that exact thing. Working with some of my research on the side is with developing uh, control techniques for prosthetic hands. So like, how can we build prosthetic hands that feel like a real hand or like work like a
I
real
mean,
hand?
I'm sure you can, bro, but like, how expensive is that?
And that's one of the big questions, and one of the issues is like, how okay, so like we made this really expensive thing, like how can you make it so that insurance companies are willing to pay for it, which is a super tricky thing because insurance companies obviously don't want to pay for very expensive
Of course
procedures for
not, bro.
people,
Of course not.
which is tricky. But if you're able to show like, yeah, like this hand is expensive, like these treatments are expensive, but look how much they improve the patient's quality of life. Look how much the patient look, and really, I mean, like kind of one of the tricky things is you have to show that like, yeah, if you invest in this device, this really expensive medical device up front, you have less cost down the line.
That's that's kind of what I come across like in the health field. As far as so a lot of people call in. They say they have dentures, but they don't want dentures. They want implants in their teeth.
Mhm.
Implants, dude. If you get all of them, it's gonna cost you like 50, 60 grand.
Mhm.
And health insurance companies do not approve that.
Yeah.
They give you dentures, which cost $2,500. You put it on, you put it out. A lot of people apparently it's uncomfortable for them,
Mhm.
but they approve it, so you can get those, no problem. But a lot of people just want implants so they can permanently have it in there. It looks nicer, but that looks more like cosmetic surgery,
Mhm.
like getting your breast done.
Yeah.
Like you don't need that.
Mhm.
You can get the dentures.
Yeah.
So that's the issue that I see across the board. And a lot of for the end users, the patients, they don't really understand that. Like, well, I should have that too. They're like, well, it costs 50 grand. Do you really need it
Mhm.
when you have this? You know?
Yeah, but I mean, so that's a non-profit group. I can't remember their name. I feel bad. Out of Utah has actually done some really interesting work where they are so they're nonprofit and they supply free rehabilitation and therapy to
Nice.
people with movement disorders, and they've been collecting a ton of interesting data. And what they were able to show is that investing in people's rehabilitation and therapy early on is more expensive, but the person recovers and your long-term medical costs go down. So you invest up front, and that means like later on insurance companies, and so they worked a lot with people with paralysis and spinal cord injury. And what they were able to kind of demonstrate is they're like, yeah, you invest a lot of money up front
Hmm.
um, into these patients suffering from paralysis, but then long term things like bladder infections, like different and like other long-term medical costs associated with paralysis go down. Like the person, and they're able to get back into the workforce quicker. So you have this patient who, sure, you put a lot of money into them up front, but they go back to work. The insurance company starts getting a return, starts getting paid back because that person's working again, and the insurance company has to pay less over the rest of that person's
Nice.
life.
We could simulate that to universities in FAFSA,
Yeah,
like government grants
yeah,
to help underprivileged kids go to college.
yeah.
They get degrees, they go into the workforce, they make more money, they pay more taxes.
Yeah, I know, and it's the same thing, and it's super interesting work, and I think that's where um, a lot of the work being done to convince insurance companies to like pay for these expensive treatments um, kind of has to
Got it.
kind of have to go has to go that way to show like sure you're paying a lot now, which
Yeah,
obviously
yeah,
the
I get
insurance
it, bro.
company doesn't want to do.
They do not want to do
Yeah,
that, bro. Trust me.
exactly.
Yeah.
But long term, like this is even better for you long term. This is better for the patient, and it's better for your company.
Got it. Okay. Next question. Elon Musk's Neuralink, bro. I just want to get into it a little bit. Do you know anything about it?
Yeah, yeah,
Can you
I'm
explain
somewhat
to us
familiar.
what it is?
Yeah, so I mean, the idea is, so they've invested a lot into the system where they try to weave these thread-like electrodes, from my understanding, um, into the brain so that you can get a ton of recording capability um, from an area of the brain, and like really kind of where they're really unique is that they're leveraging robotic surgery. Just because like threading things through the brain would be a very difficult thing for a neurosurgeon to do. And as we said earlier,
Yeah.
neurosurgery is expensive.
Hell yeah, bro.
Uh,
It's expensive. No. Yeah.
so if you could automate the procedure, you can make it like more precise, safer, and cheaper.
Uh huh.
Um, and definitely, I mean, that's my understanding of where they're currently at. They're also, I think, from my understanding, only in animal testing right now. So they have not moved to human trials.
I thought it was also so two minds could connect to each other.
Yeah, so I mean, so the idea with implanting electrodes in the brain that's kind of interesting is with you're able to just decode. That's like the term we use for it is you have this neural information that's encoded by the brain, and you have to decode that into something that you can use in a computer. Um, once you have those electrodes in the brain and you figure out a good way to decode what the person's thinking, you can do anything with it. So like, um,
Does it work reverse? You can make them do anything?
I mean, so it's actually kind of interesting is that, yeah, you can stimulate the brain to cause people to do things. And like early work 100 years ago was done where they like,
Yeah, shot the brain,
yeah,
bro.
they'd shock the brain or they'd even just like touch it in places and ask the person,
And the hand
yeah,
goes jerking off.
yeah. And
Yeah.
they'd ask the person like, what do they feel? And it was, there's some interesting work being done actively where if you stimulate like parts of the brain that are associated with like consciousness and morality, you can
Really?
actually change someone's like moral, yeah. So there
Moral
was
ethics,
moral, like
or
there's
even their personality.
exactly like, and they did it temporarily where they used I'm pretty sure they used magnetic stimulation um, to stimulate this area that's associated with the person's kind of like logical thinking, and they would ask them questions beforehand, saying like, okay, like what do you like trolley problem kind of questions, where like, okay, if you see a train going toward 10 people, do you pull the lever to divert it to one person? And they
Yeah,
would
yeah.
give an answer. They'd wait, stimulate the brain, ask the person the same question, and they'd give a different answer. So it's interesting where it's like, oh yeah, so there's like when you're putting electrodes in the brain or stimulating the brain in a certain capacity, you can change how that person thinks and acts, which is definitely uh,
Yeah, it's not
nice.
good, bro.
Yeah,
Yeah. I
yeah,
mean,
huge
or I mean,
moral and ethical
yeah, it
question.
is. It is. But at the same time, if someone's having developmental issues
Hmm.
or having severe depression, you could shot that area and get them to their serotonin levels to level up. But then again, that's also bad too because there was a study where they put some they put some brain things in some lady
Hmm.
and they gave her a lever to press a button saying you could just shock yourself and give yourself like a mini orgasm, and she
Hmm.
would just constantly do it,
Hmm.
and then they had to take her away from her because that'll kill you. They did in rats too.
Yeah, I've heard about the rat studies for sure. Yeah, and oh, geez, actually, something I was going to say, but it passed me up.
No, bro.
Yeah,
Yeah,
but
and
yeah,
rats, bro.
yeah,
And rats. But I feel like you constantly have an orgasm. You don't want more, bro, because it makes you feel good.
yeah.
And you know,
Hmm.
and eventually it'll kill you.
Yeah. Well, I mean, that's actually, I mean, it is kind of interesting. I mean, there's a lot of, it's definitely like a exciting treatment that's had some really interesting results with using ketamine to treat long-term depression, where they effectively give people ketamine as this antidepressant,
Yeah,
but unlike from my understanding at least, unlike standard antidepressants where it's like this pill that you get prescribed and you're on it for the rest of your life, like an SSRI or something like
it's in
that.
a controlled environment. Yeah, I know about those.
And also what they've found is that over the course of like 6 to 8 months, I think even maybe it's up to a year, the brain actually rewires itself and makes permanent or semi-permanent alterations, so the person doesn't need the therapy anymore.
Yeah,
Which is, I think, is really kind of this interesting idea with treating these, like using modern technology to treat these um, psychological and neural disorders.
neurological disorders.
It
You could,
kind of lies is okay. Like, what treatments can we make that the person's not dependent on for the rest of their life? Like, what can we make a treatment that cures someone of this debilitating disease like depression or other psychological diseases like permanently? Like, they don't have to.
it's called ayahuasca.
Yeah.
That's actually that goes both ways though.
Mhm.
I've heard a lot. Actually, I was in Peru like a month ago.
Oh, very cool.
And I've met different people. They did it for different reasons.
Mhm.
Some people were there just trying to get a high off of the mystical.
Mhm.
Some people like literally had depression or
Mhm.
problems, and they're there. I'm like, did it help? They're like 100%. Like I feel different now. And they did
Yeah.
it like 2-3 weeks ago. I'm like, you're not depressed anymore. They're like, no, it just snapped me out of it.
Yeah.
There's a lot of class 1 drugs
Mhm.
that are banned that do have positive effects.
Mhm.
But the thing is, I've talked to different researchers too. It could go either way, bro. It could also give you psychosis.
Yeah, 100. But so I do think so. That's like using psychedelics to treat neurological disorders.
But it works, bro. It works.
Yeah, from some of the research I've read, it's real interesting, and I think it is definitely an area to be explored. And people bring that up regularly. They're like, "Oh, but it could like make it worse."
But
And it's like, but also we prescribe
yeah, antidepressants.
or like Adderall for ADHD. We
Yeah.
prefer the stimulant, and it works. It works
works,
really great.
yeah.
It's a great medication for people who need it. But also in the same time, like someone who's taking that medication could take a ton of it and like really mess themselves up, or you could take too much of your heart medication. So
Yeah.
like I don't know, people who make that argument who say like, oh, it could go both ways. It's like, well, yeah, every medication can. Like
yeah,
if
exactly.
you take your chemotherapy and crank it up to 11, that's not going to go well for
Yeah.
you. So
But you brought up like something that could cure you, but I
Mhm.
think we should do way more studies into like psychedelic drugs.
Mm.
I mean, they even call it plant medicine over there because they're like, it's not a drug.
Mhm.
Because I guess over here it is. But like even what LSD or psilocybin mushrooms, dude, there's positive effects. There's a lot, but you could take the hero's dose, which is like a full gram, and that should fuck you up, bro.
Yeah.
But if you take like just like 1/4, it
Mhm.
does like send people on like trips. But after that, like it puts things into perspective. It rewires the brain.
Mhm.
And it does help a lot of people. I prefer meditation. I did an hour before I got here. I woke up in the morning, went to the gym, swam, and I did an hour of meditation. But even with that, you do it for 30 days straight, and it kind of rewires your brain.
Yeah. Yeah, no, there's been kind of some interesting studies done into like how people who meditate regularly, how their brains do function differently, and like you can actually measure it. And
Yeah,
we were
now
talking
you can. Yeah,
about like using EEG
yeah.
to measure that, and it was pretty cool. At least some of the research I've read into it is that people who meditate were able to control.
Their feelings and emotions.
Or the like actual I trying to remember the general idea of the study was they were measuring EEG and using it to control a prosthetic hand or some robotic device, and people who meditated were able to control the device way more accurately and learn to use it more quickly because they were able to be like, okay, I'm like activating this spot of my brain effectively.
Yeah.
And they were able to do it more precisely than people who didn't meditate. And so I think that's a super interesting area of like, how does meditation affect the brain on like a physiological level? And I don't think a lot of people know, but I think it's something
They don't. I mean,
should
that's
look
something
into.
I'm fascinated with. The way it's going is the space between your conscious mind and your unconscious mind is the bridge is
Mhm.
less and less. So you're able to get what you want more. And what do sick people want? They want to be healthy, bro.
Yeah.
And it's like something they're very motivated about. Like if I'm motivated about like manifesting money or something like that, yes, most people aren't gonna meditate on that stuff too much. But if you're really sick, dude, and you just want to get healthy, so you could just use your hand to eat or brush your teeth, you're gonna be
Mm.
very motivated.
Yeah.
And I mean, if you meditate, you know, you just gonna focus on that one thing, dude,
Yeah.
just to become healthy. So I feel like that helps. But the science is lacking a little
Yeah.
bit. They're barely scratching the surface.
Yeah. No, and it's interesting because I mean that's something we've hit on a couple times.
Like the
Or,
placebo effect, bro.
yeah.
Like you said, you know a thing or two about that. People are able to do it. They don't know exactly how it works. Do you know a thing or two about the placebo effect?
A little bit. I mean, so I just like on like the general medical field, the placebo effect is this idea of like if you
Trick people. In
yeah,
a
if
sense.
you give someone a placebo, you're effectively tricking them, but they can like get better. And the
I,
underlying mechanisms, I have no idea how it works,
I'm
but
I'm studying that. I've been to meditation retreats about that.
mm,
I've even read a study yesterday, actually, funny enough, where the doctor says, "Hey, this is a placebo effect, and I'm giving it to you," and the patient literally knows, and they still take it, but they
mm,
still get better, bro.
yeah, that's
So,
super interesting. Yeah.
yeah, the doctors are like, "We don't know how it works." The patients are like, "We don't know how it works." Doctors are like, "We don't mind that it works."
Hmm.
Patients are like, "We don't mind that it works either." But they're like, literally, they're like, "Hey, this is a placebo effect. Pretend it's the real drug.
Hmm.
Just take it, but it's only salt pills."
Yeah.
And the patient's like, "Oh, okay." And they take it, and they gradually actually do get better. So
That's
there's,
yeah.
yeah. So there's something that happens on a unconscious level
Hmm.
where it ends up like helping them heal themselves.
Yeah, and it's actually really interesting how much the placebo effect can account for. So like in like drug development and drug studies for different like psychological issues like depression
Yeah.
or things like that. Um, the placebo medication, I think the rule of thumb that I'm familiar with can account to up to 50% improvement in symptoms, which is
Bro, that's
it's
a
wild.
lot.
Yeah, so
That's a lot. 50%?
from a placebo, yeah. So for like treating, so like some forms of depression, like they when they give someone a placebo, they've reported that up to 50% of the population like reported improvement sometimes, which is wild. That's such an obscene amount. But obviously something's happened. Like I definitely think it's an interesting area of research.
Yeah.
Um,
But you're doing it to yourself. So most people don't understand the placebo effect is when you gradually get better by something that you think is good for you, but
mm,
it's really just neutral. It's nothing like giving someone a salt pill
mhm,
and telling them like, "Hey, it's going to cure your what do I call it? Your arm that's not working anymore." Like
yeah.
there's been a 99% effective rate
Mhm,
when really it's just a salt pill. And the
mhm,
person takes it and they're like, "Oh yeah, I can feel my arm getting better."
yeah.
It's like, look at this, and you're like, "What the hell?"
Yeah.
But actually does 50%, dude. That's a lot.
Yeah. No, yeah, no, it's actually super interesting. I at least I'm not familiar with any of like the underlying mechanisms of like how you're tricking the brain, but also
You don't
the
have to, bro. You're on the way to becoming a doctor.
yeah
Just
uh
give him the salt pill. Nah.
it is kind of funny. So for stroke therapy where I work, kind of one of the classic treatments for improving hand function after a stroke is you take so after a stroke you end up with someone where like their left or right side of their body no longer functions properly. So, say you have someone who suffers from a stroke, they end up with the right side, their right hand is weakened.
That's from the left side of the brain.
Yeah, exactly. Um, but like the kind of classic treatment for it is it's called mirror therapy. And what they do is they take the affected hand and they hide it behind a mirror so that the person can't see it. And then they place their hand that still functions properly in front of the mirror and they pretend that they're moving both hands at the same
And that's
time.
called mirror neurons.
Yeah. Well, and the interesting thing is like that's. I mean, obviously there are other therapies, but that one has been shown to work, and it's just the person looking in the mirror, seeing their hand move, thinking it's their other hand, like pretending
Yeah.
effectively, and they get better. It's shown to be an effective therapy for stroke rehabilitation, which is super interesting because you're just tricking
Yeah.
the brain into thinking that you're like, oh no, you are moving your hand. But it's enough to get the brain to start to try to find new pathways and build things. And I'd be curious to see with future research if that's kind of how the placebo effect works too, where you trick the brain into saying like, and into thinking like, oh yeah, I am doing this thing. I am getting better. I am whatever you're trying to treat. And just by doing that, you rewire the brain to think that, oh, yeah, I've been taking this treatment and now I'm fine. Therefore, I'm fine. And obviously, like things like that aren't going to work for, like, if you have like a heart defect. Like, you're not going to be able to cure that with like a placebo effect. But for like,
Maybe. I don't know, bro. You're saying that now.
yeah,
Anything's possible, I believe.
well, yeah,
Well, here's the thing. Right now, you're saying you're tricking it, but the more and more I'm doing research and go to meditation retreats, it's you're reprogramming your brain.
yeah,
You're not. I mean, yeah, you're tricking it now because the patient doesn't want to go through like 3 hours of meditation every day for the next 3 years. So you just trick it into it. That's the easy way and the fast way. I guess like if you reprogram your brain to just function differently, like you said, after you have a stroke, it starts using different parts of the brain it's never have, and boom, you just get that arm to work again.
yeah. Yeah, no, and I mean, yeah, I use the phrase tricking just because
No, but
yeah,
it is. You
yeah,
are tricking someone.
yeah, you're
literally
effectively.
tricking them.
Well, and it's funny because like sometimes so with like mirror therapy, like the person and like you were saying that earlier, where there was like a research done where they gave someone a placebo and told them it was a placebo,
Yeah.
but somewhere in the brain was like, oh no, we're taking something for X Y Z. And it's the same thing with mirror therapy, where the person knows they're not moving their hand. Like the hand, they know their hand doesn't work, but some part of their brain is saying like, "Oh, this is working," and it's like they're because they're seeing it in the mirror. They are the person is aware that they're like the person themselves isn't being tricked, but they are tricking their brain into thinking it. At least that's how I like to think about it, which is interesting.
That's crazy. I actually read that research yesterday. I think it was in Washington or Maine.
Mhm.
Dude, they literally the doctors are like, yeah, we are telling the patient this is a placebo, and we're giving it to them, and the patients are fully aware it's a placebo.
Mhm.
The doctors don't know how it works. The
Mhm.
patients don't know how it works, but they're both okay with it because it's doing severe improvement
Yeah.
in people. Like I think like it's like maybe a false hope
Mhm.
that gives you real hope.
Mhm.
I don't know, dude. Like I'm not a psychologist.
Yeah.
Like I mean, I've studied psychology and I have a degree in it, but just beyond my understanding. But it's interesting, dude. But honestly, I don't even care, dude. If it does help the people, let's just see how it works and make it better.
Yeah.
I mean, like the goal is to actually help people.
Yeah, yeah. Oh, I mean, and that's definitely something. It is kind of interesting working at this intersection of like technology, medicine, science, um, and this kind of field that I refer to as like neural engineering.
Neuroengineering.
Yeah,
Yeah,
where
that's awesome. That's what
so
I'm gonna title it, dude. Neuroengineering. Nice.
where as like the engineer, it's super cool to develop these like cool new technologies that do things. But then sometimes from the medical side, it's like, oh, well, really, let's try to simplify that. What's the simplest thing we can do that gets like the most improvements for the patient?
Apparently, trick them, bro.
Yeah, exactly. Well, and that's the funny thing. And so, like, obviously, like with like new technologies, and we were kind of talking about this with insurance a little bit of like definitely that's the crux of new medical technologies is like things come out and they're like new and they're sleek, but it's like how much do they actually improve the patient's life over doing it a super simple way? Like,
Yeah. But I feel like the patient, the end user, it's ultimately on them, bro. Because you can have like the best technology in the world, but if the patient's not motivated, not even a little bit, I don't know if it's gonna work properly. But if you have like amazing technology and the patient's super motivated and driven, I'm sure they'll just go 0 to 100.
yeah, and so that
Depends on what's going on.
yeah.
But gradually it is gonna help them, bro. Like I'm confident it will.
Yeah, and some of the some research done a while back is for like physical medicine and rehabilitation is kind of this idea, and it's still ongoing. They still definitely still do this, but how can we devise treatments that don't necessarily feel like treatments and that someone can take home with them? And so one of the research that at least I'm familiar with was this idea of you have these children who are born with cerebral palsy, which effectively part of their brain doesn't form properly,
Okay.
and it results in motor issues, so they can't move properly. And the study was they devised a like video game where it forced the patient to use their the weakened or affected hand to play this video game, and it showed that they did using the video game they got better over time. But really, like the main point of the study wasn't to show that they got better; it's to show like, oh, we created this therapy that the person can use that's enjoyable to use, and they can use it at home on their own. And I definitely think that's where a lot of the future of like rehabilitation and really lies, is trying to devise these therapies that people enjoy using, and they can do at home on their own. Because
And it's
definitely
easy.
like,
Just
yeah,
make their life easier.
yeah, because I mean, if
Okay.
you think about it, like one of the biggest issues is like after you suffer some injury, like a spinal cord injury or a
Yeah,
stroke.
you didn't get the press, bro.
Well, and also like how can you make it to the hospital if you're no longer allowed to drive? How do you get to the hospital to receive therapy?
Yeah.
I don't know. Like you have to either have family or you have to have some other support structure to do that. But
I mean, every week. Yeah, it's
yeah,
tough, bro.
yeah, exactly. It's a tricky issue. But and that's where I think really the future, and I think the field's definitely steering there. But I do think that's where a lot of it will go, is trying to devise therapies that people can do at home on their own and that they want to do. And it is kind of funny because I know, like, so actually, um, there's a fair, or not a fair, but there's some research that's been done with like different like video game systems that you buy. Like the Nintendo Wii was like a
Hmm.
great of where it got people like in retirement homes and whatnot to like move, and they would do like their, yeah, exactly,
Yeah,
like
yeah.
they'd sit on the sofa playing
Tennis
like virtual
or
tennis.
golf.
But they were able to show that it like had positive improvements on the
It
person's
did, bro.
life, and they actually, so in the Nielsen Rehab Hospital where I work, they have a Nintendo Wii for rehabilitating people's hand or arm after a stroke. And they'll sit there and they'll play Wii Fitness. And it's things like that like that seems like such a simple idea, and it's so cheap. Like it's the cost of a Nintendo Wii, which now I think, like, I don't know, you can go,
$200 maybe. I
yeah,
don't know.
maybe I don't, maybe less than that because it's so old. But like things like that that are super simple, and you can just like someone can just buy off the shelf,
Hmm.
do it themselves at home, and then see improvements, I think is really important.
Cool. That's it, bro.
Okay.
That's a lot of information.
Yeah.
That's good. That's good. I'm glad at least things are going the right way for
Mhm.
patients. There's more and more research coming out. I'm definitely gonna talk to you again. Thank you again, Marshall, for jumping on, teaching me more about neuroengineering.
Mhm.
I appreciate it. And ladies and gentlemen, go and subscribe, and we'll catch you next time.